All right, so we're starting our ratios. Who can tell me what they think the final score of the basketball game will be? Jordan? 60 and 40? Okay, don't tell me why yet. Does anybody have a different answer? 40 and 20?
40 and 30.
Okay. Does anybody have a different answer? Okay. I'm not going to tell you my prediction yet. Jordan, why do you think that?
They considered they had 30, so it's just half of it.
Okay, so if that's half, what would you do to figure out the end of the game score? You have one half and then another half, so you multiply by 2, yes? So that's a good reason. Oh, please. Ayana, why did you choose what you chose?
I thought I choose Russia because I didn't expect to see it the way he's saying 20 points ahead of the Blue Jays. So if they win 10 more points and they finally round
Okay, I agree with that reasoning. Yes, Ruby, why did you pick?
Okay, but I feel like Slam Dunks are 6 points, and so I just added 3 points. So like they have to give up some shots and some heads off, so they can have like an even number. So it's like not really realistic.
Okay. Okay, but you still kept the Crusader score higher than the Blue Jays score. Yes? All right, somebody over here was raising their hand. What did you want to say?
I think if they score the exact amount of points, if they play the exact
First half?
The first half, they will probably get the exact amount of points.
Okay. If I were to guess, I would probably say that the Crusaders would have 55 points and the Blue Jays would probably have 38. Who can tell me why? Wyatt? Okay. Raviana?
Oh wait.
Not quite. When they start their basketball game, what are they tired? No, they come out all energized. They're pumped. They're ready to play, right? They play so hard that first half. What happens? They get tired. They're not energized like they were, even with halftime break and getting water, right? So do you think they're going to play just as pumped up in the second half as they did the first half?
No.
Probably not, which is why I gave them less points in the second half. But the Crusaders still win. However, was anyone's answer wrong? No. Why? It was a prediction and you were able to explain your reasoning. That is why explaining your reasoning is so important. If you had just put 40 and 30 on your paper and didn't explain, I'd be like, oh, no. Because the 30 and 20 are half. How did you get 40 and 30? But explaining your reasoning that, or Ayana, that they would say 10 points ahead, I agree with that. I think that's a great reasoning, yes? And if she added her reasoning to mine that they were more tired in the second half, we made the perfect teammate. Right? So explaining your reasoning is very important, guys. Did you have a question? Okay. Mr. Moore? Your face is priceless right now.
Okay, I have a student. Now I'm back you to do it. We're going to show you some examples of other students that did it. So we're going to look at it, and I actually saw that she said, I think the final score will be halftime. And says, I think the hard enough to save 10 points ahead of the Blue Jays. So I want you guys to talk at the table, look at what their reasoning is, tell me if you can describe their reasoning, and then based on the two predictions, which team scored more points. You need to look at their predictions, figure out which one said one team will score more in the second than the other one did, and which team did they choose. We'll give you guys about 3 minutes to talk about that. Okay, what did you guys come up with? How would you describe Rubina? Terms like double. What are you thinking about?
Sometimes they're on the same thing, or really thinking, so they might feel like it's kind of like totally not increasing or something.
So what would be the math term for that? Multiplication. So Rubina
You should be writing this.
is using multiplicative reasoning. You're thinking about multiplying the numbers by 2. I may give you a hint for the other one. So then how do you describe Aaron's thinking?
Added 10 to 30.
So, okay.
Sorry, 20 to 30. So,
What?
yeah. So, Aaron added 20 to 30.
Okay. So what kind of reasoning would that be?
So, both scores were added 20, but the Crusaders were still 10%.
Okay. So
Multiplicative reasoning is going to be addition of, I like that.
that's actually pretty good. Thanks, Jordan.
Thank you.
We don't use addition, we call it. There you go. Additive.
Addition.
Using additive reasoning, where Robina multiplied them both by 2. Aaron was using additive. He just added the same amount to both. So do you see the difference? Okay, so given their reasoning, which team scored more in the second half? Crusaders by
10 points. 20 points. I mean,
so by Aaron's thinking, did the Crusaders score more than the Blue Jays in the second half? They did.
They scored the same.
Scored 20 by Aaron's reasoning. Did they score the same by Robina's reasoning?
No.
No, by Robina's reasoning, who scored more? Crusaders. Does that make sense? You see, I mean, you see your numbers, right? That went plus 30, plus 20. That was plus 20. That was plus 20. So the only number that was different in all that was the Crusaders and Rubina's reasoning. So the Crusaders scored more in Rubina's reasoning. That makes sense for you guys. And you see the numbers right there, so I'm hoping it makes sense to you. But that's going to give you an idea for this next part of what we're going to do. Everyone needs your highlighter / marking pencil. We got a couple of math terms here. Okay, our first one. Additive reasoning, as we just looked at. There we go. Focus on the use of addition and subtraction for comparison. By comparison, we also have what's called multiplicative reasoning. That one uses multiplication and division for reasoning. So we kind of already jumped the gun and answered this one. But which student used additive and which used multiplicative? What did we just say? And Aaron Is additive reasoning. So really, you guys, the big thing on that is look and see what they did to the numbers. If it's a multiplication between them, then they use multiplicative. If they're doing the same thing, if they're adding the same amount, that's additive reasoning. We have a little exercise, thought exercise for you. Follow along. I'll read through it with you. Help you break it down a little bit. Vicky and nephew Benjamin share the same birthday. They were both born on March 4th. Vicky says, today I'm 40 years old and you're 10. I'm 4 times as old as you are. Benjamin says, wow, you're old. Then Vicky says, yeah, but in 5 years, I'll be 45 and you'll be 15. Then I'll only be 3 times as old as you. Benjamin's like, wow, catching up. He comes back and says, in 15 years after that, I'll be 60. You'll be 30. Then I'll only be twice as old as you. Benjamin says, in enough time, I'll be older than you, Andy. So, here are your 2 thoughts. Is Vicky correct about how their ages change? There's our first question. Is Benjamin correct in thinking that he will eventually be older than his aunt? So we're going to let you guys talk about this at the table. We'll give you about 4 minutes to talk about, remember, you got 2 questions you're asking. What about, is Aunt Vicky thinking? What about Benjamin thinking? So discuss it at the table, write down your answer. Okay, so what conclusion did you come to talk about this? Alvin?
Vicky is correct because 40 is 10 times 44, 45 is 3 times 4 than 50, and 60 is 2 times 30, which means that she's right about the ages.
Good, are we okay with Vicky being correct?
Yep.
Yeah.
Okay. When I was walking around, that's mostly what I heard. Most people Vicky was correct. And she did use good mathematical reasoning. Her mathematical reasoning is good. What about Benjamin? That's where I was differing opinions. Yeah. Did you ever get to 1 time older than Benjamin? And then be the same age? There's some of you saying that that Benjamin's thinking was okay, really? Guys, listen. This is a concept.
But even that shows skill.
Is she right or is she wrong? Let's think about this. So, just to make sure everyone's recording here, once Vicky dies, Benjamin will have the opportunity to eventually get older than her. I actually have some personal experience on this. My dad died, man, it's about 20 years ago now. So, every July 20th comes around, and I think about my dad, because that's his birthday. Do I think of him as how old he was when he died, or do I think of how old he would be that day? Okay, so with Aunt Vicky, if she dies, does that change her birthday?
No.
Because remember, our birth is actually considered from our birthday, correct? So even if we died, I guarantee you, well, most of you anyway, you'll have someone passing along that's still going to be thinking about you every time your birthday comes around. And in their mind, they're going to think about how old you would be at that point. So given that, will Benjamin ever be older than her? No. Okay? So the bottom line, Benjamin will never be older. Does that make sense for everybody?
Yeah.
And it really does come down to the fact judge our birthday based on when we were born, and when they were born is never going to change. So she will always be older than him. But go to our next page. What we've done now, we now have a table that breaks down the different statements between Vicky and Benjamin. We're going to use V for Vicky's age and V for Benjamin's age. Show what they need in all of these statements. So we're going to do the first couple just to help everybody understand what you should be doing. So Vicky says, today I'm 40 years old and you're 10. So B is 10, 40, B is 10. Correct? So if we look at their ages, we say 40 equals 10 plus 30. Is that correct? So what kind of reasoning is that? Additive, right? So that's additive. And answer back and she said again, I'm 4 times as old as you are. So again, with our 40 and our 10, now we're saying that 40 equals 4 times 10. Correct. Yes. What kind of reasoning is that? So, this is the first one for you to make sure everybody understood what you're doing. Then we want you now to complete the last column, write what they're saying, and then say is it additive or multiplicative reasoning. And then your second point, at any point in this age scenario, which relationship does not change. So as you go through it, you're going to see one of them doesn't change. Tell me which one it is. We'll give you guys about 4 minutes to finish this one up. Should not have that difficult. I'm really shocked. Like he says, he gave you the first example. And the rest of them do the exact same thing. 7 and 5, 45, and they'll be 15. So now we've changed those equations. So go to the equation where variable, I put it on 45 equals 15 plus 30. Is that correct? Yeah. So what type of reasoning is that? Additive. Then I'll go 3 times as old. So same numbers, different equation. Now we say 45 equals 3 times 15. Is that correct? Yeah. What reasoning is that? Multiplicative. Now after 15, I'll be 60, you'll be 30. Again, we changed our starting ages. Variables haven't changed. So now 60 equals 30 plus 30. That's still additive reasoning. Yeah, we have different numbers. So now 60 equals 2 times 30. Is that correct? Yeah, what type of reasoning is that? Multiplicative. When I look at all of these different equations, what didn't change? The variables changed. You got different numbers for the variables. What did change? Did or didn't? There's one change, one didn't.
Here's the hint. Which one changed? Multiplicative or additive?
Change.
What? We did.
So, which relationship does not change? Wow, this one was a lot more difficult than I thought. So, additive reasoning did not change. So now I'm worried. Do you actually see that the additive reasoning didn't change?
Yes.
You see, every time I added 30, I always added the same amount. Did the multiplicative reasoning change? Yes, I used different numbers. Guys, that's a major key concept as we're getting into the ratios here. How we're going to be looking at them. Okay? At this point, we've given you guys a extra sheet of paper So Shannon's going to go over this part with you. We have another definition.
You will need your highlighter and the paper I handed out in a few seconds. But you do not need it at this moment. We're going to go over the top of the page first. All right, the school colors at Riverview Middle School are a shade of green and white. The art teacher, Mr. Wraith, knows that to get the correct color of green, it takes 3 parts blue paint to every 2 parts yellow paint. One way to show this is through a picture or a model. So they drew 3 parts blue paint, 2 parts yellow paint. Does everybody see that? And they're going to mix those up to make the color green that he needs for the school. By looking at the model, you can compare the 2 quantities. You can compare the blue to the yellow. What would I say if I'm comparing the blue to the yellow? That I have 3 blue to 2 yellow, yes? What if I was comparing the yellow parts to the blue parts? What would I say? 2 yellows to 3 blue parts. I can also do a part to whole comparison, meaning how many blue parts to how many parts in all. So what would I say if I was comparing how many blue parts to how many parts in all? 3 blue parts to 5 parts in all. And what would I say if I was modeling the yellow to total? 2 to 5. Does everybody see how that works? These are called ratios. This is where you need your highlighters. A ratio is a comparison of 2 quantities that use division. After you highlight that definition, I want you to write it on the page that I handed out to your table in the top box under ratio where it says definition. I'll give you about a minute. All right, so you should have written definition for ratio on your handout in the first box under the word ratio where it says definition. Let's get back to our page in our book. If we look at the comparisons that we made based on our model, the 2 comparisons on the left are part-to-part comparisons, meaning we compared a part of the mixture to another part of a mixture. Does that make sense? The ones on the right are part-to-whole ratios because we compared a part of the mixture to everything in the mixture. Does that make sense? Any questions about that? So there are 2 different kinds of ratios, part-to-part ratios and part-to-whole ratios. So they said, suppose he wants to make another shade of green and he needs 2 parts of blue paint to 5 parts yellow paint to make it. Compare the quantities of blue and yellow paint in Mr. Wraith's mixtures by writing possible ratios for each site. So they want you to do the same thing we did at the top. Do 2 part-to-part ratios and 2 part-to-whole ratios, and then answer what is the difference that you see between your ratios. So use the top ratios as your example. Any questions? All right, I'm going to give you about 2 minutes to do those. 4 ratios and answer the questions underneath. Go for it. Who can tell me 1 part-to-part ratio for the new mixture? 2 blue to 5 yellow. What's another part-to-part ratio for the new mixture? 5 yellow to 2 blue. This is just like a fact family, guys. We've been doing those for a while. What about a part-to-whole ratio?
5 yellow to 7 whole.
5 yellow to 7 total. And another part-to-whole ratio, right? It should not be hard, guys. All right, who can tell me what's different between my part-to-part ratios? What's different? Right here.
the numbers on each ratio are just swapped.
So the order of the parts is different. All right, what's different between my parts to whole ratio? Come on, guys, it's not hard.
The part numbers are different.
They're both using a different part of the mixture. All right, let's look at the page I handed out to you. We're going to finish that up. You should have already done the definition in the top box, so I'm not going to do that one. What ratios look like? So let's use the example we just did. We know that ratios look like 2 blue, 2 5 yellow. Yes? I can also write them with 2, a colon, and 5. That's the 2 dots in the middle. I can write them as fractions, 2 to 5, or 2 out of 5. And I can write it as a sentence. For every 2 blue, there are 5 yellow. So there are 4 different ways that you can write ratios, and I need you to be familiar with all of them. Got it? The 2 we're going to use the most is the colon and the sentence, colon. But we will be using all of them at some point. What do these ratios mean? We know a ratio is comparing 2 quantities. So if I look at this 2 to 5, what is that telling me?
That like there's two parts of your whole is blue, and 2 parts of your whole, 5 parts of your whole is red.
Okay. Can somebody say that a different way? Yes. So every time I have 2 gallons of blue paint, what do I know? I'm going to have 5 yellow. So if I have 4 gallons of blue paint, I make 4 by 2 and 2, yes? What do I have with this 2? 5 gallons of yellow. And what do I have with this 2? 5 gallons of yellow. So how many yellows do I have if I have 4 gallons of blue paint? 10. That's what it is telling you, that every time you have 2 blues, you will have 5 yellow. Make sense? Any questions about that? All right, get that on your paper, please.
And then we're going to go back into the books again. And we're going to do a couple of real world examples.
Keep these papers, guys. These are the ones you can use on test.
For real. Okay, we'll do this one together real quick. Well, it's because we're running out of time. I'll get to the homework. Okay. Proving find all kinds of different ratios. Let's look at a couple different things. Let's do students wearing glasses. So if you are right now wearing glasses, raise your hand. So I got 1, 2, 4, 5 on my side. 6, 7. Okay, 8 people raise their hand. Now raise your hand if you are not wearing glasses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So we have 8 who are wearing glasses. Couple of different pieces in this. ratios. Your order is everything. So how it is said is how it is written. So this one started by saying first, students wearing glasses. So what is that first number? People who are wearing glasses. Second says students not wearing glasses. So that means the 29 is not wearing glasses. So you have to make sure that your numbers always line up with what is being talked about when we're doing ratios. So if I go the other way and I say number of students not wearing glasses, the number of students wearing glasses, what does that ratio look like? 29 to 8. Does that make sense for you guys? Now, when we talk about a part to whole ratio, now what we're doing is we're trying the part to the whole. So if I say students wearing glasses is my total number, what numbers would I put down? Good. 8 and 7. Where did 37 come from? Everybody, so I add the 29 and the 8. If I do not wearing glasses to the total, what does that look like? Pardon? Awesome. This is making sense for you guys. Okay? Could I also compare this number of students with blonde hair to those who are not blonde? Can I compare students with blue eyes to students who don't have blue eyes? Can I compare the number of students wearing shorts to those not wearing shorts? I mean, really, is there anything we could not compare?
How much?
Anything you want to do, you can compare. That's going to become very important when we do our homework. Okay. This last one we're going to go together. Leonardin is adopting a new nickname. They're choosing between two, the Tigers or the Lions. They did a school-wide survey and tallied all the votes. Each homeroom analyzed the results of the school-wide survey and reported the results in a different way. So these are all reporting the exact same result. We're just doing it in 4 different ways. So what we want you guys to do is see if you can now take what we've talked so far about the ratios and look at how they've written it and do 2 things. First, describe the meaning of each statement, and then identify which describe ratios. So there's 2 parts: describe the meaning, identify which describe ratios. If they do describe ratios, there is a second part. Tell me, did they do a part to part or a part to whole? So you're just going to list the 4 homerooms: 6A, 6B, 7A, 7B. And for each one, you're going to answer those 2 questions. Find those meanings. We only got 7 minutes left in class. I'm going to go over homework. About 2 minutes. I'm going to do this with you. All done. That's okay. But hey, sad, tired, outnumbered lines 240 to 160. So they gave an actual count of the votes. That's the whole school, right? So they gave actual counts for each. Is this a ratio? Yeah. Got 2 numbers I compare the quantity. What type of ratio is it? Part to part. Okay. 6B. What did they talk about? They just gave the difference, right? If I take 240 and I subtract 160, I get it. I get that. So they gave the difference. It's not a ratio. No, only one number. One number. The only way I can have a ratio with one number is the third second number. 7A. They said Tigers outnumbered Lions by a ratio of 3 to 2. So that is actually the simplified version of 240 to 160. So they gave a simplified ratio. What type of ratio was it? Like I already gave you the hint, that one was a ratio. Whether it was a what? Part to part. What is the difference between what 7A did and what 7B did? 7B, you think there's only 8 students in 6th grade in the whole school? No. So what kind of ratio did they give? Simplified. And what type of ratio was it? Part of whole. 5 votes. So for every 5 votes, that's the total. They gave the part who voted for the target. That makes sense for everyone? Okay, let's go to our homework. There's quite a few I need to make some notes on for you. Go to 181. Guys, I gotta go through quick. Got 3 minutes left. I need 2 ratios. Right about at least 1 part to whole and 1 part to part. So give me 2 ratios, fill one stuff. Example, give them 5 and 6 out. By sports, part sci-fi, Steven, 2 comedies. Write the ratio. We've got 2 forms, colon, and fractional form. I'll give you the first one. So sports to sci-fi. So I'm going to say 5 sports, 2. Sci-fi was 3. That is fractional form. 5 sports, 2, 3 sci-fi. That is colon form. So every one of those needs to have 2 answers. 1 in fractional form, 1 in colon form. So you're going to do all 6 of those. Second part, identify which of the ratios in question 1 are part to part and which are part to whole. So you just list A through E. Tell me which type is each. Some are part to part, some are part to whole. Go to the back page. Because we didn't talk about this, here's your chance to hear it. Write the percent that represents the shaded part of each grid. Each 100th grid represents a pole. So to write the percent, all you need to do is count how many are shaded. For part A, how many are shaded? 2, how do I notify that that is percent? Percent sign. That should be the easiest homework we've given you this year, guys. Just make sure you're writing all of them. Please note, did I label what my numbers were in my ratio? Yeah. Okay. Any questions on your homework? Okay.